Have you ever stopped to think about the one material that really just silently powers our entire world? I'll give you a hint. It's not silicone and it's not steel. Nope. It's an ancient metal that helped launch entire empires, that sterilized wounds for Egyptian pharaohs. And today, it is the absolute bedrock of our digital and our green future. We are talking about copper. And today, we're going to go on a 10,000-year journey to figure out how this one single element conducts, well, pretty much everything.
Okay, so let's dive right in with a simple but honestly kind of mind-blowing example. It all has to do with two pennies. They look almost identical, right? But one of them has a hidden superpower that the other one just doesn't. So here's the deal. On the left, you've got a penny made before 1982, and it's a solid 95% copper. But on the right, a penny made after 1982, that's basically a zinc coin with just a super thin copper coating. The US Mint made that switch because, well, the copper itself became worth more than 1 cent. But the really fascinating difference here isn't about money. It's about a strange, hidden biological power. Because check this out. If you put both of these pennies on a petri dish that's just teeming with bacteria, something incredible happens. The old high copper penny creates this clear zone of death all around it, but the new one, bacteria grow right up to the edge, no problem. So what in the world gives this old penny its strange germ-killing superpower? Well, to answer that, we've got to zoom in. No, like way, way in. We need to look at what makes copper, copper, right down at the atomic level. The whole secret starts right here with element 29 on the periodic table. See, copper has 29 electrons, but that last one, way out on the edge, it's kind of a rebel. It's not held very tightly. So when a bunch of copper atoms get together, this one electron just becomes free. It's not tied to any single atom anymore. It's completely free to just roam across the entire structure of the metal. And where does it roam? Through this absolutely beautiful atomic setup called a face-centered cubic structure. Now, I know that's a mouthful, but you can just think of it as a perfectly organized crystal city. It creates what's basically an electron superhighway. It's an incredibly efficient, tightly packed structure that gives all those free electrons these wide-open, continuous paths to just flow wherever they want. And that is the crucial point. This unique combination, a sea of free electrons and a perfect superhighway for them to travel on, is what gives copper its famous superpowers. It's why it's such an amazing conductor of electricity and heat. It's why it's so easy to pull and shape into wires. And yeah, it's why it's a natural-born germ killer. This is exactly why our entire world is wired with copper. I mean, sure, silver is actually a slightly better conductor, but it's wildly expensive. And aluminum is way cheaper, but its conductivity is, well, it's just not that great. Copper hits that absolute perfect sweet spot. You get near-perfect performance at a cost that makes it practical enough to, wire up an entire planet. Okay, so let's go back to our killer penny. That same free-roaming electron that makes copper so great for wires also makes it incredibly reactive with microbes. When a bacteria lands on a copper surface, the metal launches this just devastating multi-part attack. It punches holes in the cell's wall, it floods the inside with these destructive things called free radicals, it completely scrambles the DNA, and then it shuts down all the essential proteins. The poor bacteria is literally dismantled from the inside out. It's brutal. So yeah, copper is an atomic marvel. But these incredible properties, they didn't just stay in a lab somewhere. So let's zoom back out and see how they scaled up to build and connect our entire civilization. I mean, copper's resume is just staggering. It was the very first metal that humans ever figured out how to shape, which kicked off our entire mastery of materials. Then we figured out if you add a little bit of tin, boom, you get bronze, and that launches an entire historical age. Fast forward a few thousand years to the 1880s, and its conductivity makes it the backbone of the electrical age, literally lighting up the modern world. And then, just in the last couple of decades, that same property let it replace aluminum in microchips, enabling the digital lives we all live today. At every major leap forward, copper was right there. And that germ-killing power? Oh, that is not a new discovery. This quote here is from the oldest medical text in existence, the Smith Papyrus. More than 4,500 years ago, Egyptian doctors knew that putting copper on wounds helps them heal. They didn't know about bacteria, of course, but they saw the results. They knew it worked. Copper is also just incredibly durable. I mean, just look at the Statue of Liberty, that iconic green color. That's not rust or decay. It's actually a patina. It's a stable layer that forms over decades and acts like a natural shield, protecting the 80 tons of pure copper underneath from all the elements. While iron just rusts away into nothing, copper basically builds its own suit of armor. And when it finally came time to light up the world, there was really only one choice. For his very first central power station in Manhattan, the project that would change everything, Thomas Edison laid down over 100,000 pounds of copper wire. So, from day one, the story of modern electricity has been the story of electrons flowing through copper. And that brings us to today, because this ancient metal, it's now facing its biggest and, you could argue, its most important job ever, powering a sustainable future. And this chart really shows you the sheer scale of the challenge we're facing. An electric vehicle needs almost 4 times as much copper as a gas-powered car. 4 times. And that's because of its powerful motor, the battery system, all of it. The same is true for renewable energy. A solar or wind farm needs way more copper per megawatt than a fossil fuel plant. Our green future is quite literally built on a foundation of copper.
So here's the fundamental problem. We've been mining the easy-to-get, high-quality copper for centuries. We've kind of picked all the low-hanging fruit. Today, the quality of the ore is so low that we have to dig up and process over 100 tons of rock just to get 1 single ton of copper. And that has a massive energy and environmental footprint.
Right now, about 1/3 of our copper comes from recycling, what some people call the urban mine. That's all the copper that's already in our old wires, our pipes, and our electronics. And if we're going to meet the massive demand of the future sustainably, that 35% number, it needs to grow. And it needs to grow fast. Because the payoff for doing that is huge. Recycling a pound of copper uses 85% less energy than making it from brand new ore. A copper atom just doesn't wear out. You can melt it down and reuse it over and over and over again, infinitely, with no loss in quality. It is the ultimate circular material.
So that leaves us with the defining question for this incredible element. We need more copper than ever before to build a sustainable world full of EVs and renewable energy, but our main way of getting it, digging it out of the ground, is becoming more and more unsustainable. So bridging that gap, figuring out how to recycle more and innovate, that's not just some technical problem. It's one of the great challenges of our time.